These are MCQ questions from last year board exam question paper. Ag++ 1 electron gives Ag E naught value 0.80 volt. Fe2++ 2 electron gives Fe E naught value minus 0.44. Find the E naught cell. So we know E naught cell is equal to E naught cathode minus E naught anode. Here, the cathode will undergo reduction and anode will undergo oxidation. So, Fe is changing to Fe2 plus, that's the anode, and Ag plus is changing to Ag, that's the cathode. Also, we can understand from the values, E naught value higher means that will act as cathode, and E naught value lower value means that will be anode. So, cathode minus anode means 0.80 minus 0.44. So, when we add, we will get 1.24 volt. So, our option is D. Which of the following solution of KCl will have highest value of molar conductivity? We know molar conductivity is equal to K by C. So as concentration increases, molar conductivity decreases. Or molar conductivity and concentration, they are in inverse proportion. So least concentration, highest molar conductivity. So our option is A. The correct cell to represent the following reaction is, here zinc is undergoing oxidation to Zn2 plus, so we can represent the half cell Zn/Zn2 plus. Then salt bridge. Now Ag plus is changing to Ag, that's the reduction reaction, so Ag plus slash Ag. So our option is D. Delta G and E naught cell for a spontaneous reaction will be, for a reaction to be spontaneous, delta G should be negative. And for a reaction to be feasible, E naught cell is equal to E naught cathode minus E naught anode, that should be a positive value. So negative and positive. So our option is C. Coleridge gave the following relation for strong electrolyte, lambda is equal to lambda 0 minus A root C. We know molar conductivity becomes equal to the limiting molar conductivity when the concentration tends to 0 at infinite dilution or at 0 concentration. So here concentration is 0. So our option is B. Cathode reaction during the charging of a lead storage battery leads to the formation of, we know at the time of discharging we can write the equation Pb plus PbO2 plus then the electrolyte sulfuric acid to H2SO4 gives 2PbSO4 plus 2H2O. This is the reaction at the time of discharging, that is when the battery is in use. So recharging time, we can reverse the equation. Recharging time or charging time, we can reverse the equation. So 2PbSO4 plus 2H2O gives Pb plus PbO2 plus 2H2SO4. Pb plus PbO2 plus 2H2SO4. So here the products Pb and PbO2. So our option is C. How many Faradays are required to reduce 1 mole of MnO4 minus to Mn2 plus? In MnO4 minus, the oxidation state of manganese in MnO4 minus, it is plus 7. Because we know oxygen minus 2, 4 oxygen minus 8, minus 8 plus X equal to minus 1. So manganese is in plus 7 oxidation state and that changes to plus 2 oxidation state. So when we balance the equation, let us add 5 electron. So 5 moles, that is 5 Faraday. So our option is D. Corrosion of iron is a decomposition, photochemical process, electrochemical process, reduction process. We know corrosion is an electrochemical phenomenon. The number of Faradays passed through a solution of copper sulfate to produce 1 mole of copper and oxygen. So in copper sulfate, copper is in +2 oxidation state. So Cu plus 2 electrons gives Cu. So from that we can conclude we need 2 moles, that is 2 Faraday. For 2 moles electrons we need 2 Faraday. So our option is D. A voltaic cell is made by connecting two half cells represented by half equations below. Which statement is correct about this voltaic cell? Here from the E naught value we can understand the higher one will act as cathode and the E naught value lower means that will act as anode. So Fe3 plus is getting reduced to Fe2 plus and Sn is getting oxidized to Sn2 plus. So Sn is oxidized, and when we calculate the voltage 0.77 minus 0.14, so that will be 0.91 volt. So here we can say Sn is oxidized, anode will undergo oxidation, so Sn will be oxidized and voltage of that's correct statement. So our option is B. For half reaction 1 to 4 are shown below. 2Cl minus gives Cl2 plus 2 electron. 4OH minus gives O2 plus 2H2O plus 2 electron. Na plus electron gives Na. 2H plus 2 electron gives H2. Which of these reactions are most likely to occur when concentrated brine is electrolyzed? During the electrolysis of brine solution, out of Na plus and 2H plus, we know the E naught value of hydrogen is more, so hydrogen is liberated at a cathode. And out of Cl minus and OH minus, we know due to over potential of oxygen, chlorine is liberated at a anode. So 1 and 4 are the correct options. So our option is B. Which of the following cell was used in Apollo space program? In Apollo space program, hydrogen oxygen fuel cell was used. The unit of molar conductivity. Molar conductivity unit Siemens centimeter square mole raised to -1. Electrolysis of aqueous solution of sodium chloride gives chlorine gas at anode instead of oxygen gas. Correct statement, because due to over potential of oxygen. So both assertion and reason both are correct statement, and reason is the correct explanation of assertion. So our option is A. Lambda m for weak electrolyte show a sharp decrease when the electrolytic solution is diluted. So molar conductivity for weak electrolyte increases with the increase of dilution. For weak electrolyte, degree of dissociation increases with the dilution of solution. So assertion wrong and reason correct. So our option is D. Limiting molar conductivity is obtained by extrapolation of lambda m versus C raised to 1 by 2 curve of strong electrolyte. That's correct statement. We can find out the limiting molar conductivity of strong electrolyte graphically. Lambda m for weak electrolyte is obtained by using Caldrash's law. That's also right. But reason is not the correct explanation of assertion. So our option is B. Conductivity decreases with a decrease in concentration of the electrolyte. That is correct statement, because we know conductivity is due to number of ions per unit volume. So concentration decreases, conductivity also decreases. Number of ions per unit volume that carry the current in a solution decreases on dilution. So assertion and reason both are correct statements and reason is the correct explanation of assertion. Our option is A.